Okay, so we are going to be talking about the MVC architecture and the FLUX architecture, how it differs, what is the problem with MVC, and how can FLUX help us achieve better control of our applications and our code. So, as you probably know, the MVC architecture is quite old. It's used originally to build like traditional web applications, where you had your browser, you went to a URL, which basically means you want to request some state of an application. What happens is that request goes to the server where you have your controller, which is in its most simple way just a router. This router takes the request, collects some state from your application, and the state of a traditional web application is mostly database entities. So what it does, it goes into the database, collects some state, it puts that state into a view, which is basically a template that populates some dynamic data inside the template, and then sends that HTML string over to the browser again. Now, if you want to do a new request for a state, or you want to change some state, you either have to trigger a new URL or you have to post a form. And that's how it works. You have your router that takes some request, it collects some data from your database, it produces a view and sends it to the browser. And that's very nice. It's a very nice architecture. It works very, very well. But things has started to change because we are not only building our web applications on the server anymore, and we do not only have databases, entities in our database as the state of the application, and we have started to use JavaScript in the browser. So in traditional MVC architecture, you just get an HTML string to the browser. There is no state in the browser. As I said, you have to trigger a URL to change or get some new state. So things has become a lot more complex. And one of the best tools, I think, at least the first best tool for it, was Backbone JS. And Backbone is built very much like the MVC architecture that we did on the server side. As you can see here, we have our model concept, which reflects an entity in the database. We also have a view, and the job for the view is to have a template, which we see here, and it renders that template and passes the state from the model, which we can see here, into that template and then puts it into the DOM. What differs though is what's happening on this line, and that's how the view will have a connection directly to the model, which was not possible in traditional MVC. And I'll come back to that. Last but not least, we have the router, and as we can see, it has a URL. And when that URL is hit, it grabs a model, it produces a view and push that model into the view, renders the view and puts it into the DOM. So that's exactly how it worked on the server side, and it works very, very well. What differs though is what happens after the view is put into the DOM. As we can see here, let's say you have a list with users in a view and you click one of those users. What happens is that you go to the router of Backbone and it will grab a model for that user, fetch it from the server and put that view into the DOM. What happens then is you get this split controller role of in the view and in the model, because your view is actually able to change the model directly and get data from the model. It doesn't need a router to do that. And the model itself talks to the server side. asks for new state, tries to change the state, stuff like that. So already here we see that things start to change when we move into the browser environment. What really started to change when we moved into the browser environment is how we handle state. We have loads of new state, and it differs from what we did on the server side. As I said, on the server side, we mostly had entities in a database. Maybe we had a session on the user and stuff like that, but most of it was entities in a database. In modern web applications, we have a bunch more state, and I like to call that state just app state or application state. And what I mean by that is the state that only lives inside the browser. It has nothing to do with the database or the entities or the session or whatever. It's the state that you use to produce a fantastic interface for your users. So I thought to go more into that. I have an example. So let's take a look at this button. It's a green button that says play. When I click it, it's going to turn into a yellow button and the text should be pause. So we're going to move a few years ahead here. We're going to look at AngularJS, which is also like an MV whatever type of framework. And what we have here is a controller. And this controller is going to contain a state. And the state is playing, which is currently false. And it will have a method that will reverse this is playing state. And we also have a template. And this template has the controller attached to it. And the button uses Angular directives to choose the correct class of the button. Should it be green or should it be yellow? And we have the click directive, and yeah, you probably know this stuff. So the problem here is, what if a different controller, like a future implementation or whatever, needed this state of is playing? And this is the core issue. It's like in Backbone.js, there is no concept of handling application state, only database entity state. Yes, you would probably put it in your view, like we did here in the controller, but that is the main problem because you can't scale that. You have locked the state inside a view or your controller. And it is very, very hard to scale that. And we're going to look at some examples now how we would solve this problem with Angular. And then we're going to look more into FLUX and how it would work there. So back to our example with Angular. We could trigger events. And the problem with doing that is that the event handling in Angular is linked to the scope chain. So this is not to like say that this is a bad thing, and it works differently in other frameworks, but it's just to take the concept of triggering events and what issues that can cause. So in this case, we have our toggle play method, which just flips the state of is playing. And if it is playing, it emits a play event. And if it's not playing, it emits a pause event. This lets other controllers know about this change. The problem is that either we have to emit it up the scope chain or we have to broadcast it down the scope chain. And maybe we had one controller on above or outside this controller, and we had one controller inside this controller. So my point is, you have to emit and broadcast, and that just doesn't feel right. Also the problem with the events being like linked or attached to the scope chain is that you cannot reach like sibling controllers who are not part of the same chain. Another problem which is very general with events is that should you like trigger a play and pause event, or should you just have one event that's called like play toggled and then pass the true or false value? And the problem with that is you might have one implementation that only needs a play event, for example. Maybe you have one implementation that prefers play and pause, but you have another implementation that would prefer play toggled with the value. So things start to get messy. What we also could do is use the root scope. And this works actually quite nice in a smaller application. We put the state on the root scope instead. And by doing that, we ensure that any controller implemented will have access to this state. And as you can see, we also flip the state on the root scope. The problem is with scaling is that when you build a larger application, you start to put a bunch of stuff on this root scope, and it can become a bit messy. So it's not an ideal way to solve that issue. We also have nesting. This is also Angular specific, but the thing is that any controllers that are nested within the controller that handles this is playing state would automatically get access to that state. The problem here is that what if you needed to change the DOM structure? What if you put like a new button inside a nested controller and you wanted to just move that button somewhere else in your DOM structure? You couldn't do that because it's connected to your controller and you have created this dependency. So that is not a good idea at all, really. And you still would not be able to reach this state from controllers like outside this my controller here. So that's not a good idea either. What is a good idea though, and again this is Angular specific, but the good thing about Angular is that they have a more state-specific concept. Like I said in Backbone, which is an older framework, there is only this model concept that is scalable. In Angular, we have services. And what I've done here is that I've created a service that is called appState. And it returns an object that has this isPlaying state. In my controller, I can now inject that app state, and I can just attach it to the scope as app in this case, so that I can say app.isPlaying inside my template. In the method in the controller, I change the isPlaying state inside app state. And the good thing about this is now any controller, any future implementation can just inject this app state and it works. So you have a very scalable solution. And as we can see here, we have a second controller here, which basically did the same as up here. It injects app state, it creates an app property on the scope and puts the app state inside that. So that in the template, you can just say app.isPlaying and it just works. So I would say that this is the best way to scale applications in Angular when we talk about state. But there are some issues with this also. It's not only that we have a bunch of new state, we also want to react to that. We also want to react to state changes differently. In traditional MVC on the server side, we only wanted to reflect state in the UI. It's the only thing we could do because we could only pass HTML to the browser. So it was only a reflection of the state in the application that we wanted to put into our UI. But as we are running JavaScript in the browser, we have the possibility to also trigger a function when a state changes. So let's take an example of this. We still have our play button that changes to yellow and the text pause when clicked. But we also want to trigger an interval when we click play. So we change the state to is playing true, and that should trigger an interval which will update a duration state that is reflected in the UI. So let's have a look at how we could do that with Angular. I have updated the app state service. It now has a duration state also. The play controller does not have any changes, but I have added a new controller here called duration controller. And that one also takes app state, and it also injects the Angular interval. Again, we just hook the app state to the scope so that we can point to, well, specifically the duration in this case. And to react to a change to the isPlaying state, like to trigger a function, we have to use an Angular method called watch. So this method watches the app isPlaying state and then triggers this function. So if it changes to true, it will set up an interval, and that interval each second will update the app state duration. And when it changes to is playing false, it will just cancel that interval. And this works actually very nice. The problem is that the only way, and again, this is Angular specific, but the only way to react to a state change and trigger a function is to do it inside a controller. But now we had this great concept of handling state inside the service, but you cannot inside the service figure out if a state changes. You can only hold the state, and that is a problem. Well, in my opinion, it is a problem. And what I specifically mean here is that this watch and the interval and updating that state should be inside the service. It should not be inside the controller. A controller should just grab state, push it into a template, and react to interaction in the template to change the state again. So what is like the problem here? First of all, watch is expensive. It's like we haven't really figured out a very good way to react on state change with triggering a function. Now, luckily for us, in the next version of JavaScript, we will get object observe, which will change all this in a very good way, I think. But for now, the architecture we use has never been like built to handle it because it didn't need to. As I said, on the server side, you could just pass hot HTML to the browser. You weren't able to react to state changes in the same way we can do now. But a bigger problem is that there's so many different ways to handle state, and if you don't have a clear concept of handling state, you will probably mess it up. I messed it up a bunch in Backbone, in Angular, in Ember. It doesn't matter because there's just not a strong enough concept of handling this kind of state, in my opinion. And it's also about the mental image inside your head. When you are able to change your state from a controller, as we saw in Angular, we grab the state from a service, but we also change the state in the service from the controller. So the line that goes between the controller and the service has an arrow in each end. And if you try to visualize this in your head or on a diagram, things start to get quite messy. Now this picture is of course the worst image I could find of MVC, but you have probably been like ripping your hair off thinking about, oh, how does this application work? And it is a problem using the MVC architecture. And I believe it's because it's an architecture that was never meant to handle the kind of applications we try to build today. So let's have a look at FLUX. Now, Facebook FLUX is an architecture, just like MVC. It's not a framework. It's just an architecture. It's a way to think about how you build your application. What's so special about Flux, like the main concept, is this one-way flow of state. As I just said, in MVC, you often have lines with arrows in both ends. That does not happen in Flux. Your state will always run down through your application, and to do any changes to that state, you have to start at the top of your application. So let's go through this diagram. Now, a component in Facebook Flux is React.js. So I think this has been a bit of a confusion, like React.js is Flux or React.js is a framework or something like that. But React.js is just a component library, a brilliant one, but it's just this green part of the diagram. It's not a complete tool to build an application. You need more than that. And what you can do through these components is trigger an action. So whenever you want to change the state of the application, you have to trigger an action. And this action could be triggered from a component. It could be like a WebSocket message from your server. It doesn't matter. The only way to change state in your application is to trigger an action. And this action is handled by a dispatcher, this red box up here. And the dispatcher has one or multiple stores registered to it. So when the action reaches the dispatcher, it will notify all registered stores about that action. And they will figure out by themselves if they want to act upon that action or not. If they do, they will trigger, well, first they will of course do some state changes inside this store, and then they will emit an event. And this event can be listened to by a component. And when it triggers, it will collect state from the stores. So the stores will not pass the state changes on the event. They just say something has changed. And then the component itself has to grab the state it wants to update itself. What's kind of special about Facebook Flux is that you have this top component that is basically your app. And that's the component that collects all the state. And what it does is that it kind of shoves that state down through its child components throughout the whole application. So every time there is a state change, the whole application will actually re-render. Now, if you don't know React.js, what I'm going to say now is very important, because when I say it re-renders the whole application, it doesn't do what like Backbone does. It doesn't produce a whole new set of HTML and replaces the DOM with that HTML. What it does is that it renders the application to a string inside JavaScript. And the first time it will of course put that string into the DOM and you will see the application. But when a state change occurs, it will do the same string rendering again, and then it will match that string rendering with the last one. And all this happens inside JavaScript. And then it will actually figure out what has changed and do the minimum amount of DOM operations to make the DOM up to date with the new state. And this works very, very well. And if you think about it, if you have any experience with Backbone, what Backbone did very well was have this model, and when the model changed state, it would render the UI again. So it will always be a reflection of the state of your model. But this was like inside one view, and you could have a bunch of views in your application. In Facebook Flux, though, it renders the whole application, and the whole application makes sure that it reflects the state of the stores. So the stores decides everything, and the whole application is rendered every time something changes. And that is actually a very good idea. It makes it a lot easier to handle changes in your application and make sure that the UI is correct. So Flux is an architecture. It's not a framework. So like in MVC, you have a family of frameworks like AngularJS, you have Ember.js, Backbone.js, you have Knockout.js, and a bunch of other frameworks. In Flux, which is quite new, you don't have that many options. You have the Facebook dispatcher, the store, and React.js, which are kind of like the elements or the components you need to build an application with Flux. There's also a framework called Fluxor, which uses React.js, and we have JFlux. So JFlex uses jQuery as kind of like a foundation for the whole framework. And jQuery is really, really, really powerful. And it's something that you already know. That, like when I say that jQuery is powerful, it's not powerful in the sense that if you use it wrong and just do a lot of DOM operations, it's slow. But it's not because of jQuery, it's because of the DOM. But in this case, jQuery is used internally in JFlex and provides an API that you have much more a much more of a relationship to than with, for example, React.js, which is brand new and has a very different syntax and what you're used to. But it works basically the same way. You have your components, and the only way to do state changes in your application is to trigger an action. But there's no dispatcher in JFlux because the dispatcher just passes an action. There's really no reason to have it, in my opinion. And you also have stores, but the stores listen to specific actions. So it's not like the actions reach all the stores. They only reach them if the stores actually are interested in that action. Then they change their internal state and they trigger an event, either a general update event, or you can also trigger specific events. And then we have our components. Also in JFlex, you probably have a top component that is your application, or maybe at least only a few of them. But all the components live by themselves. They are not depending on their parent components to pass state down through the components. They all live totally isolated, and they listen to stores and they update themselves. So you don't have this concept of re-rendering the whole application. Only components that uh, notices a state change they are interested in will update themselves. But they do it in the same way as React.js. So they will only do DOM operations necessary and make sure that the DOM is updated and in sync with the state of the application. Again, you have this one-way flow that makes it a lot easier to reason about your code. Now, if you have never looked at React.js, you might be, and I've talked to a bunch of people who react to React.js in a negative way. And the reason for that is the syntax. It's putting HTML inside JavaScript. Traditionally, we have been building applications with templates, and it's even been called a separation of concern. And that is might be right in many situations, but I feel that the state of your component or your view or your controller is so tightly linked with the HTML you want to produce that it should be in the same file. Like in Angular, they say that, okay, you can use this controller with any piece of HTML, but do you ever do that? Don't you build a very specific application where you have specific controllers with specific HTML related to that controller? And that's the way we're going with the components with Flux. It's you put all this stuff together that is tightly connected, and you only work in one file when you work on a component. That said, components are a lot smaller than what you would put in a template and a controller in, for example, Angular. But again, it's a lot easier to work with smaller components because you have this state handling that does not depend on other components. So let's have a look at some JFLUX code so you get an idea of how you would work with building an application. What we see here is that we define some actions first. Usually you put this in your own file and you have like a list of many different actions. And these actions kind of looks like a manifest for your application. Like, what is this application able to do? Because the list of actions is the only way to change state. So it explains how you change your state in your application. And that's actually very, very nice. Then we define a store. And a store is defined with a function. And this function can have some privately declared variables, and that is where you put the actual state. Then you can define some methods on this store, and the methods are state mutators. They are the methods that are triggered when an action is received in the store. And when a method has mutated the state, it will emit an event, probably just an update event, but you can emit specific events if you want to. Now, this example is of the button and the duration. And what's very interesting here is how we handle this reacting to a state change with a function. Because since we are trying to change the state with an action, we can both do just like mutate the state like we normally do to make it possible to reflect that in the UI. But it's also very, very easy to trigger a function. So in this case, we have this toggle play method that is triggered when an action is passed to this store. And it will reverse the state. Then it will trigger this toggle interval, which is the same code that we had inside our watch. But instead of having this two-way data binding, we have to emit an event to tell the application that something has changed. Further down here, we set up this listener to the action toggle play and pass it to the toggle play method up here, which again will trigger this method also. What the store returns is an object with methods to collect state. So in this case, we want our application to be able to grab the isPlaying state and the duration state. Looking at the component, we start to see a very close comparison to Backbone. And that is to make it easier for you to start using FLUX and try out that architecture. Especially if you come from Backbone, or if you have tried Backbone then Angular, it's probably something you will remember. So a component is very much like a view in Backbone or a controller in Angular, but you have the template inside the component. So let's go through this small snippet of code. We first define an init method, which runs, of course, when the component is created. And this listens to an app store, and it listens to the update duration event. So it doesn't listen to this general update event, it listens to a specific event. And that is very nice if you, for example, want to just react to some state change inside a component. If you want to reflect state in the UI, it's okay to just listen to a general update. But if you want to react to something, you don't have to like keep a notion of, okay, what is the previous state, what is the new state. The store just tells the components, this is what you should do now. And that's an important part of handling state. Well, back to the code. We are listening to the App Store for the update duration event. and we tell this component to update itself. And when that happens, it will run this render method again, and it will compare that to the previous render and do the update in the DOM. So in this case, whenever this component updates, uh, this specific section will change. And that's the only part in the DOM that will also change. Um, Looking more into the render method, it receives a compile argument. And this compile argument is a function that you call and return from render. And this compile function takes unlimited number of arguments. And the arguments build up a DOM structure. As you can see, it looks just like DOM. And JFlux will compile that into something that can be represented in the DOM. So let's look at a second component here that has some more code in it. So in our second component, we see some more code. Again, you will probably recognize this from Backbone. We have this events object that lets you define, in this case, click on the button, run the toggle play method. We also have an init method here that listens to the App Store and the update event, and then updates the component. Our toggle play method only triggers an action. So you never do any state changes inside a component unless that state is 100% specific to that component. Then it's okay. But that is the issue with scalability, is that you start putting all this state inside your components or your views, and when you do new implementations, you don't have access to it. Always thinking actions and stores makes it easier for you to think scalability. You will first figure out if should this trigger an action and should it be handled inside the store. And then if that's like you see that you don't have to do that, then you can consider putting it inside your component. We also have a render method here, which defines what I call a render prop or a render property. What it does is define a button class property that's an object. And you might recognize this from Angular. You have an object where the key is the class name, and the value is either true or false, meaning that this class name should be included or this should not be included. Looking at our HTML definition, we have a div and it has a button. And here we can see how this render property is used. All typical attributes like class, disabled, checked, value, and stuff like that has their JFlux counterparts. And the JFlux counterparts point to the component. So in this case, button class, it looks into the component, it sees button class, and there's some logic here that will be run to handle this object and reflect that correctly in the UI. And again, we point to the App Store, check if it's playing, displaying pause or play, and then we just insert our duration component. So you can compose components. And last but not least, we render the component to the body. And again, since this is based on jQuery, you see a lot of jQuery stuff here. And you can very easily use jQuery plugins and stuff like that. So this is what I wanted to show you theoretically about JFlux and how it differs from the traditional Facebook Flux architecture. And the point here is that Flux is an architecture. MVC is an architecture. MVC was used to build traditional web applications on the server side, where you did not have any state in the browser. But as we moved on, putting more and more state into the browser, opening up new possibilities of handling state, reacting to state, we haven't reconsidered the architecture we use to do that. And it's a good thing Flux has arrived and is challenging the way we use MVC and think about how we build our applications. Because scalability is a problem. Things are starting to get very, very complex. And hopefully, Flux will be a very good contribution to build more complex web applications. Thanks for listening to this talk and have fun using JFlux.